All right, so let's do this thing. Percent composition and of compounds. So check this out. CHO. All right. For example, ethanol. Ethanol is written as C2H5OH. C2H5OH. Got it. The mass of each element is present in molar mass. Blah blah blah. So, how much of each element is present in each thing? Let's try it on this thing right here. So, we have carovine, a substance that occurs in two forms that have different arrangements of the atoms, but the same molecular formula. One type of carovine gives you caraway seeds, which is are seeds, their characteristic smell, and other type is responsible for this smell of spearmint oil. Okay, so when you chew spearmint gum, this is the formula of the thing that causes that smell in spearmint gum. Got it? So it's C10H14O. Okay, cool. C10H14O. I don't know why I spaced out that chemical formula or the equation that much. I just did. All right. Let's figure out exactly what percentage of this is carbon and what percentage of this is hydrogen and what percentage of this is oxygen. Sound good? All right. So first we need to do is we need to say, all right, let's figure out the molar mass of carovine. Molar mass of carovine. All right. Well, actually by weight and numbers of atoms, Sophia. The molar mass of carovine is C10H14O. So C was 12.01, and I need to multiply that by 10. Got it? H14, H was 1.008, and I need to multiply that by 14. Sound good? And O is 16. Now I need to multiply that by 1, but we're good there. So, are you on a calculator? Oh, you're typing up your notes? Dang, typing up your notes? That's a lot of work, dude. You have a calculator? Can you be my calculator, man? Alright. Let's see. I would say that that's 1,201 plus 14 plus 16. I'm just giving you guys the ballpark figure. Of course, actually, fine. What is 14 times 1.008? 1.008. 14.112? Alright, so this would be, what is 1201 plus 14 plus 16? Alright. This is 1,201. 1,231. 1,231.112. Does that correspond with the answer they got? Huh. Oh, I'm so dumb. You're right. I'm sorry. This is 120.1. I was multiplying by 100, not 10. All right, sorry. What's 120 plus 14 plus 16? I apologize profusely. 150.1. 150.1 grams for every 1 mole of carovine. Sound good? 150.1 grams for every 1 mole of this stuff. So, I guess the question is, what is the percentage of carbon that's inside of this? All right. So, if we want the percentage of carbon, we know that let's see. We know that there is 10 moles of carbon for every 1 mole of caravine. Does that make sense? I mean, if you look at the formula, if you have 1 mole of this stuff combined, how many moles of carbon do you have? We have 10 moles altogether. Does that make sense? Of carbon, that is. And then we want to convert this into, like we want to use things that we know. So I would say I can multiply this by 1 mole of caravine divided by 150.1 grams of this stuff. And then I can also do 1 mole of carbon for every 12.01 grams of that stuff. So this thing cancels out with this cancels out with that, and really I have 10 times 100 or 10 times 12.01 divided by 150.1. Basically, I mean, this kind of makes sense, right? Like if you're saying, if I have 150.1 grams of this caravine stuff, how many grams of carbon do I have? 120, right? So the percentage is 120 divided by 150. Please, what is 120.1 divided by 150.1? 120.1 divided by 150.1. Bradley, hey dude, be my other. I mean 12 times 10.
Oh, okay, I see.
Be my other calculator, man, and get up on that. It's what? No, it should be a smaller number than there. Yeah, 120 divided by 150. 80% equals 0.800006. Something like that, right? Yeah. Actually, 2 zeros and a 6. Doesn't matter because I'm converting it over to percentage, so this would be 80%. Sound good? I mean, technically, I probably should give it in better scientific notation and all of that, or significant figures and all that kind of stuff, but it's about 80%. Are we cool? Maston's completely confused. Maston, did you just get here? All right. Anyway, that's percent composition. Let's see if we can move on, because that wasn't so bad, right? All right, let's try another one of their examples. And I think this example is just doing the same thing backwards. All right, here we go. Determine the empirical formula of a compound that gives the following percentage after analysis in mass percentages and has a molar mass of that. Okay, fine. So let's read the problem, because there's lots of numbers in this problem. Let's try this one. All right. I know that the molar mass of this stuff, whatever this stuff is, I don't know. Apparently there's Cl, there's carbon, and there's hydrogen in there. But I don't know what the ratios are. I don't know exactly which, how much of chlorine and carbon and hydrogen there are in each of these things. Are we cool? So let's see if we can figure this out. And I'll be honest with you, I'm just kind of going through this and we'll see what we can do. We know the molar mass of this stuff is 98.96 grams per mole. Cool? And we also know that chlorine takes up 71.65% of this mass. And we know that carbon takes up 24.4 or 27. of this mass. And we also know that hydrogen takes up 4.07%. How do I know all this? It came straight from the problem. Nothing magic. I'm just writing this stuff down. Are we cool? All right. If the whole thing weighs 98.96 grams per mole, how do I figure out how many grams per mole of chlorine I have in this? Do you guys know? All right, I'll just tell you. You multiply this by the percentage of chlorine, right? So, trusty calculator man, take 98.96 and multiply that by 0.7165. Take this number and multiply it by this number, but the decimal version of that. So it's 0.7165. And Sophia and Bradley, please jump in on that action. Because I'm not sure my calculator man is quick. Are we doing this on Wednesday? I'm going to try to come up with a really fun and cool lab, but yeah, I think that we might. All right, so it's what, 70.9048? All right, so how much grams per mole of chlorine do we have? Well, that's 70.9048. Got it? All right. How many grams of on Wednesday do we have to attend virtual class? Yes. On this Wednesday we're going to attend virtual class if I'm going to do more of a tutoring, teaching kind of based thing. All right. How many grams of carbon do I have? So let's go through all of them. How much carbon am I dealing with? If I have 98.96 and I have 24% of it is carbon, how much grams of that am I dealing with? Yeah, if you can come in, please still come in. You can still totally come in. I think that I have a lot of fun teaching you in person. All right. Come on, let's go. Let's go. Quick. So how many... Oh, you're not even on it. All right, fine. 98.96 times 0.2427. And Bradley, while you're at it, can you convert the hydrogen? Because I'm not sure my calculator guy is doing this job here. I'm just teasing, man. I love you. You know I do, right? All right. 24.44? Okay, all right.
Oh, no. I think I did that wrong.
Multiply 7. No, he's doing another one.
Oh,
Multiply 98.96 times 0.2427. Is that what you did?
Okay. Oh, no. Wait. Times.
0.2427. 24.01. All right, so how much hydrogen is there? There's 24.01 grams per mole. And how much... No, this is how much carbon there is. How much hydrogen, Bradley? And you're saying 4.027. All right. 4.027 grams per mole. You have a question. Emily. Oh, okay. I'm sorry. Random person standing right next to me. What do you have a question about? Oh, okay. The reason why we move the decimal place 2 times to the left is because when you're multiplying, when you want to find 71% of something, you multiply it by 0.71 because the decimal version of a percentage is just, you move that decimal place 2 times to the left. You remember that from like way back when, right? All right, and everyone understands where I'm getting these numbers from? Is this confusing? Is this hard? This isn't bad at all, right? All right. By the way, how many chlorine atoms, or how many chlorine, not atoms, but how many moles of chlorine am I dealing with here? So, I know that if I had 98.96 grams of this stuff, my chlorine would be 70.9048. But Bradley is saying that that represents 12 chlorine moles of chlorine. Bradley, how are you getting that number? Magic. The equation. Which equation? What are you talking about? Which equation are we talking about?
Okay, so do you understand the significance of the carbon cycle? Huge, right?
From before. Kind of. What I would need to do is I need to go down to the good old periodic table. Now, where's my periodic table? I deleted my periodic table because I wanted to show you a radical party. Look up a periodic table.
Oh yeah, that's funny. So
And I remember this periodic table for some reason was, all right, here we go. Chlorine is 35.45 grams for every mole that you have in there. And apparently we have, how many? 70.90 grams. So, how many moles of chlorine? If 1 mole of chlorine weighs 35 grams, and I have 70, all right, fine. All right, here we go. Here we go. All right, it's nice and shiny. There we go. We got chlorine. It's right here, 35.45. If I have 35.45 grams, I mean, 1 mole of chlorine is 35.45 grams, and I have 70 grams of this stuff. How many moles of chlorine must I have been dealing with? You just take 70 and you divide it by 35.45. 2. We cool? So apparently, in 1 mole of whatever mystery substance we have, there are 2 moles of chlorine. How many moles of carbon are we dealing with? Because we have 24.01 grams. Also 2, because carbon is 12.01. Fair enough? Alright. Also 2. So carbon 2. How many moles of hydrogen do I have? 4. Well, that makes sense too, because 4.077 divided by roughly 1.008 is 4. All right. So apparently, and I'm not sure if this is exactly how the formula goes, but it's Cl2C2H4, which I'm almost curious to know if what that element is, or what that chemical is. Let's see what Cl2C2H4. Oh, they don't really. Oh, here we go. Oh, it's not really anything as far as like. I mean, it was an unknown substance, so I guess there's no common name for it. But whatever. Okay. Does that make sense? Was that hard to do? That wasn't that hard, right? You guys get this? Like. I really think that you guys are freaking out about moles, and it's not really as bad as it's gonna. It doesn't get worse from this point. I don't think it gets worse. I think it's actually gonna get easier. To be honest with you, I think we made it through the hardest part of it about it, and Bradley's like, I don't believe anything you say because everything you say is easy is always hard. And I'll say to that, fair enough, fair enough. So. Are we cool with this problem? I mean, the next couple of example problems are very similar to this. All right. Balancing equations. We're going to talk about balancing chemical equations. All you need to know about balancing chemical equations, it just takes a lot of practice. All right? All right. But here's the way you need to do it. Say that we have, let's see, chromium compounds exhibit a wide variety of bright colors. When a solid ammonium dichromate, a vivid orange compound, is ignited, a spectacular reaction occurs, as shown in the 2 photographs. Ooh, I want to see this reaction. Oh, sweet. That's cool. Looks like a mini volcano. All right. Anyway, you guys don't care. You don't, do you? I know you guys are just like, just show me how to do it. I don't care. All right. Although the reaction is actually somewhat more complex, let's assume that the products are solid chromium oxide and nitrogen gas, consist of N2 molecules and water vapor. Balance equation for this reaction. All right. Okay, cool. So we know that, let me show you how to balance an equation. It's actually not that bad. Here's what I do. NH4 2 Cr2O2 is apparently burned, and it yields chromium 2O3, a solid. It yields nitrogen N2, and it yields H2O. Sound good? As a gas. The problem is there's supposed to be numbers out in front here. And we don't know what those numbers are. So we have to figure out what those numbers are. That's it. This game really, all right. I'm debating on whether or not I should teach you guys the tricks, and I'm actually really debating against it. I think that the best way to learn how to balance an equation is just to do a bunch of them, and you play with it really. And there are certain tricks, but these tricks that I came up with are tricks that I've actually gotten good at because I just did a whole bunch of them. So I almost don't want to take that experience away from you. I want you to experience that. Anyway, I'll show you folks how I set things up. It's pretty straightforward. Let's see. I take a look at this and I ask myself, well, what elements am I dealing with? I've got nitrogen. What else do you see? On the left side. Hydrogen. Okay. What else? Come on. Anyone? Cr, chrome. Oxygen. Good. And on the right-hand side, I have the same. Nitrogen. So on the left-hand side, I have, how many nitrogens do I have? 2. Perfect. On the right-hand side, so we'll call this the left-hand side. I will call this the right-hand side. On the right-hand side, how much do I have? 2. Good. Awesome. On the left-hand side, how many hydrogens do I have? 8. How many hydrogens do I have on the right-hand side? Was it? 2? Yes, exactly. How many chromes do I have? This looks like CH, but it's CR. How many chromes do I have on the left side?
8.
I have a 2. It's a 2.
Oh, it's 2.
Sorry. How many chromes do I have on the right side?
2.
2. Good. How many? It's a 4.
Oh, 8.
This is a 4. This is why you guys were saying 16. Sorry. Yeah, that's NH4. That was not a 4. Okay, all right, fine. All right, I apologize. I'm writing on a computer screen with a small little pen. All right, give me a break. All right, you ready? How many oxygens am I dealing with on the left side?
2.
2. Good. How many oxygens do I have on the right side? I've got 4. Count up all the oxygens on the right side.
3.
I've got 3 in the first one, but I've also got that extra O on the right.
Oh, okay.
So I've got 4 altogether. Does that make sense? I'll be honest with you. I think the best way to do this. I mean, there's techniques, and I'll tell you what. Why don't we spend our Wednesday lab going over how to balance equations and doing stoichiometry? It's gonna be all right because I'm out of time already. I don't have any time to teach you guys.
5 minutes.
All right, I'm out of time already. Why don't we go over doing that kind of stuff? Cool. All right. Do you have to come in for that? I'll make some worksheets. I kind of want you to come in for that one. I just feel like you get better. Yeah. I mean, if you're going to come in for math, come and stay. Just stay. All right. Let me finish this off, though. All right. So here's the thing. What I would do is, if I were to put a number 2, let's see. I have 8 hydrogens over here on the left side, and I only have 2 on this side. So I'm betting that there's going to be a number 4 in front of that. Does that make sense? Because if I put a 4 in front of the H2O, that means I would have now, instead of on the right-hand side, I would now have 8 hydrogens. Are we cool? Yeah? But I'm also going to mess with my oxygens. I will now have 4. I will now have 7 oxygens. Well, that's a problem. Okay. I'll tell you what.
Wait, why did you add the 4?
Okay, wait. Let me just check real quick. All right. Why did I add the 4 in front of the hydrogen, H2O? Well, I wanted to balance out the hydrogens that I'm dealing with.
Oh, okay.
Okay? You guys see that? Here's the problem, though. Well, see those dashes right here? There should be numbers in front. We call those coefficients. Let me just write this out a little bit cleaner. There should be a number out in front here. The coefficients. But we don't know what those numbers are. So balancing equations is all about finding those numbers. These little dashes are numbers that they're supposed to go inside there. When we put those numbers out in front, this means we have 4 moles of H2O. Right? Because it can't be a 1, 1, 1, and 1. We know that because, look, they're not balanced. The left-hand side has different amounts of elements as the right-hand side. So we want to balance them out. Okay? So, here's what I'm going to do. Oh, wait, by the way, there's a 2 here. I'm kind of thinking, if I put a 4 here, okay, and everything else was 1, then what happens is I now have how many hydrogens on the right-hand side?
6.
Nope.
8.
8. Because there's 4 H2Os. And each H2O has 2 H's, so then there's 8 altogether. Does that make sense? Right. So that would be 8. But that messes with my oxygen, doesn't it? The oxygen now ramps up to 7 over here. Yeah, and that's a little weird. 7 oxygens. Because on the left-hand side, I had 2 of those things. So, before I mess with the oxygens on this one, or before I put the 4 in there, I almost want to say, by experience, I would put a 2 here, just to try it out. Okay? Let's write down our new numbers. This would be 4, 16, 4, and 4. Does that sound good?
Okay, so the scale is from
the nitrogen
okay.
would be, I would need to put, okay, wait.
Okay. If you have a change from 7 to 6, it's not just like 1, it's actually exponential.
Oh, shoot. I'm sorry. I screwed up something. Here, I'll show you what I screwed up. Here's what I screwed up. I accidentally wrote down a 2. That's supposed to be a 7. I couldn't see it. It was small. Alright, so then this was 7. Got it? 7. There. That makes a difference, because I'm wondering, how the hell am I going to balance this equation out? No. This should be a 7. Okay, now balancing this is actually really easy. What would you do? I would just add a 4 here. Because we know that that's going to make this an 8, and this is going to be a 7. And look, it's balanced. Woo! That's it. Just make sure you write down your equations correctly first. Yep. So, your balanced equation is going to have a 4 out in front. And that's it. Wait, what just happened? I mean, I don't understand how to explain it any better. I mean, it's that. If you want, I'll do another problem for you. It's actually not going to be that bad. Let's see. Let's try another one.
You just choose a number to balance it.
You just kind of play with the numbers until you get it. All right, here we go. Let's see. The unbalanced version, NH3 plus O2 is NO plus H2O. Okay. NH3 plus O2 is equal to NO plus H2O. All right. Let's list out the 3 things we have. We've got nitrogen, hydrogen, and oxygen. On my left-hand side, I've got 1 nitrogen, I've got 3 hydrogens, and I've got 2 oxygens. Sound good? LHS. On my right-hand side, I've got 3 oxygens, and 2 hydrogens. Okay? I didn't do anything. I just kind of tallied up all the stuff on the right-hand side as the left side. That's an NO. That's a nitrous oxide. Nitrogen and oxygen. Got it? All right. I kind of would approach this as almost like clearing fractions, or almost like cross multiplying. So let's see. In order to balance out the hydrogens, I would need to multiply this by 3 and this by 2. Does that kind of make sense? Because if I multiplied this by 2, this would make this thing 6, and this would make this thing 6. Are we cool? But that messes with other things, like this now becomes 2, and this becomes H2, so that would be 1, 2, 3, 4. This would be a 4. Does that make sense to you? This is just a middle step. I mean, I didn't really do anything. I kind of saw this as kind of a cross-multiply game that I was going to play. Cool? Now, my oxygen, or my nitrogen is messed up over here, because I have 2 nitrogens on this side, so I'm going to put a 2 out in front here. That makes this thing a 2, and this thing now becomes a... How many oxygens do I have? I've got 5 oxygens. Shoot. Any thoughts? Okay. I've got one more trick up my sleeve. And I'll tell you what, it's hard for me to teach this to you without teaching you the tricks that I've learned. The trick is, I don't like multiplying by fractions, but I'm going to multiply this one by 5 halves. If I were to multiply that by 5 halves, this would become 5. Because if I have 5 halves O2, that would be how many oxygens would I have? I would have 5 oxygens. You never see fractions inside of this equation. So what I'm going to do is I'm going to clear it out by multiplying everything by 2. Sound good? So if I have, this would be 4 NH3 plus 5O2 is equal to 4NO plus
But a lot of this
6H2O.
or,
All right, I'll tell you what. The dust has settled. Let's clear it out. Let's figure it out.
but a lot of
Nitrogen,
things are weird.
hydrogen, oxygen. Did we successfully balance the equation? How many nitrogens, hydrogens, and oxygens do you see on the left-hand side? How many nitrogens?
4.
4. How many hydrogens?
Yeah.
12. Good. How many oxygens?
Wait.
Oh no.
10. There's 5 O2s.
Oh.
Good. Awesome. On the right-hand side, how many nitrogens?
Well, I
4.
suggest-
How many
I'm not sure if you
hydrogens?
know, but I suggest you just- 'cause I go
12. How many oxygens do you see?
as you read, look at the first 5 questions, and then do your reading.
10.
Yeah.
There's 6 here, and there's 4 from here.
I mean, like, you're not gonna memorize everything.
There we go. We balanced it out. Those are the numbers that go in front. And now you've seen a little glimpse into the mind, crazy mind of Mr. Dalday and how I basically just solved out a bunch of these. And you want to know the trick that I came up with after a while? Is that fraction thing. I said, if I put a fraction there and then I clear out the fraction, it all works out. That's it.
Runaway
Wasn't that bad? And it's really just all about counting the number of elements you have at the beginning and the end.
So you see,
Are we cool? If we can get through this, then Wednesday's gonna be kind of fun. Believe it or not. All right. Talk to you later.
So in our polls, all
I need to make some homework for you guys. Well, no, your homework's due already, but yeah. All right, cool.